So house number 2 is you are given an array of numbers and the question is here to find the maximum amount of money that you can steal considering these are arranged in a circle and you shouldn't rob any two adjacent houses. So if this was a linear case, my like let's suppose I have just two elements. In that case, I go with either try to rob my last element or I skip it and I go for the first element. So, or I want to drop this, skip the one before this and go for the district. So it would be something like solve I will be equals to considering I drop the current item, I go for I minus 2 because I can't drop, like there's no point of considering I minus 1 and I shouldn't. And I'd say this plus my current nums of I have something like this. But let's say I don't want to drop the current item. So you have an option to consider the one before this. So you just solve I minus 1. So this is the case where there is a possibility of you choosing either you choose this or you do not choose this, right? And given the house is arranged in a circular manner, say I have some one, two, let's say A, B, C, D, E. So I here first, I just don't consider the last element. Then here I'll get what is the maximum till here, or I just do not consider the option of first one, then you can consider E and maximum till here. There's no way that you can this here, the original way will try to include whatever you already have. It just takes the maximum. There's no way that you can say if it is considering the first element or last element or not. But here you are defining that you are not going to consider one of the two items, either first or last, and you can take the maximum of that. It's just the original as first and last. And other than that, everything else you can use the same logic that I've just mentioned here as house number 1. So the code goes like this: DP1, both the DPs I have n minus 1. It's not and DP of 0, DP of the first, considering the first one only right now. Then the second DP, index 1's DP will be the maximum of 0 and 1 elements. That's true. And since I'm considering from 1 to n minus 1, You just take from 2 and minus 1 and get all the items, right? So now, for the second DP, I have 1 as a first element, so my DP of 0 will be this. My DP of 2 will be considering arms 1 and arms 2. And DPs and DP of, what is this? It should be 2 to n minus 1. How is this even working? Is this right code? N minus 1 only. So n minus 2 is the maximum. And bullshit. Bullshit this one. So for I in the range of same 2 to n, can consider dp of I as same thing should be working. dp of I plus dp1 minus 1, I minus 2, or dp1, but here dp2, 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 dp2. This is unnecessary. Okay. Okay, nums of I minus. Am I missing out on the nums? Think no. I'm considering the current list in the height of list index 2 to n minus 1, right? And you have to take I plus 1. Think that's it. Yeah, so that is about house number 2, and going to the next one, delete on earn. So delete and earn. Given an integer array, you want to maximize the number of points you get by performing the following operation. Pick any number, delete it, earn this many points. Afterwards, you must delete every element equal to nums of I minus 1. So, is my sharing working? Okay. So, afterwards, you must delete every element equals nums minus 1 and every element equals nums plus. So number of points you can. So basically, if you have considered one of the elements, like if I have considered 3, like here you can see delete 4 to earn 4 points, and you can't consider 3 and 2. Number of nums is, so consequently 3 is also deleted. Nums is equals to 2. Delete 2 to earn points. You get a total of 6 points, right? And here you can perform the following operations: delete 3 and earn 3 points. And you will just have 2s and 4s which should also be deleted, and you will be left with nothing. That will be your maximum. So I can think of here is, I'm thinking, mm, If I take one, I shouldn't be taking another one. I'm taking minus one. So let's say I have them in sorted. Are they sorted? No, maybe not. And once they are sorted, and if I don't have duplicates, but list of numbers, I'm thinking of considering that way. And for each point, I should be able to, like at 4, mm, I can actually either take it or not take it. And if I take it, I should be skipping I minus 1 value. And it's not even like I minus 1, just before. And is the numbers working one after the other? Like, do they have consecutive numbers or not? Let me try adding one test case. Something like this 1 and 2. Oh, let's say return 0. Obviously, 1 and 2 will work. 1 and 10. So 1 and 10 is expecting 11. So if I delete something, how can I track? Okay, so here I won't have any way of keeping track of what numbers I've already chosen. No, it's not like I was actually even thinking of consider an extra index for DP. So if say till now I have only one index which is I, which is early in UDP right now. But I need to also have an idea of what all already are deleted, and based on that, can I proceed with deleting of this for even for taking that current item to into consideration. I need to keep track of my previous elements, which is actually a really difficult task. Can't just keep track of items till now in recursive manner. That too, it is recursion. So the idea over here is just take a space, um, and since these are integers, just um, just take an extra space which actually indicates the the value as the index. Oh, counter and all doesn't work. So I have, what is the maximum? Is the maximum? How do I know what is maximum? So 4, he's saying, and NEMS is also to go 4. 10 power 4. So, mm, so for the same numbers 2, it's 0 or something in English. Then 1, 2, 3. And let's take an extra. But each number in nums, what can I do? Can go nums 2 plus is equal nums 2 of the number. Let's see its number. Then I have the nums 2. And now these are the values that that particular number can add to the final value. So for let's say BPS this, and so either I consider the current item, then I shouldn't consider I minus 1 item, means 2 plus plus nums 2. The value I have in nums 2, I maybe then I shouldn't consider I can go up till minus 2, so I should be considering from 2 whether BP of 0 will be 0, since the value of 0 is 0. But if of 1 is I think now it's 2 of 1. How many ones I have? So that's it. The answer will be at the last item. You can close the print statements. And then there is next one, decode ways. Okay. I just written down the possibilities. I consider it as a single digit number and consider a double digit number. Either I can have 1 and 0 to 9 next to it, or 2, 0 to 6 next to it. That's it. That's it. These are the only possible solutions. And how can I check the number of possible ways? Let me take a minimal value. Say I have a single digit number. Okay, say 3. So I'll take this and consider my possibilities as only 1. Obviously, one single digit is 1 only. But let's say I have a double digit number. It can be something like within within this or something like this. So let's first begin with 99. Then I have 9. Considering 9, considering 9, but I don't have 1 or 2 before it. Or I don't have 1 or 2 as the first element, I minus 1 element. So I should consider singles and single. Either like there is like single plus single or double or not double, right? If this is not under any of these two, then it's not possible. That means 0. If it's a double, that means 1. If it is a single, that means also 1. So I'd rather consider it as check this and I minus 1. So keep single and single only. So I have solve of I is equals to I'd say solve of I minus 1. I should be adding it's a possibility, right? Check if if I is 1 to 9, then I'd rather say sum of and, and if that is not the case, and if I have 0 before me, or I'd rather consider this as or if this number I minus 1 start 10 plus ith number is between 11 or 10 to 26, then I'd say minus 1. Okay, this is possibility, and I consider one plus my solve of I minus 2. But am I handling the case where it is not possible at all? Right? So I'm thinking of beginning it with a negative number or a minus infinity. And even if I add something, or I'll keep 0 and check zero's case. So if it is between these two and this is non-zero, this is non-zero. So here you can say that right? And if my sum is 0, I'll just say 0. So yeah, let's go to solving this. I I'm just thinking if I will needing a extra DP. I think no. So DP of 0 for everything in the range of n, and n is length of this string given. So DP of 1 is equals to 1. But I would think about this. I'd think about if I think I can keep n plus 1, and if you are coming till 0th index, that means you are successfully figured out things till the numbers. So dp of 0 is 1 and dp of 1 will be 1 if the first index is it numbers or string. Okay, string int of string of 0 is less than equals to 9 and greater than equals to 1. Less than equals to So let's begin with the values of calculating the dp. So for I am range 2 to n plus 1, so dp of I will be, I'll just write the loops first. If my current element is between 1 to 9, which is this, but string of I plus 1, sorry, I minus 1. So this is within the range, and my dp till I minus 1 is not equals to 0. Then I'll go ahead and apply my dp as f1 plus dp minus 1. Equals to the f1. And then this is then equals to minus 2 10 plus minus 1 is less than equals to 26. Then see this without 23, but go ahead and return the things. Okay, so the plus is equals to, and I'll check if I have a test case like 0, a test case of 8 will be the result. Or like 8, 0, 8. Oh, sorry, I forgot to consider 10. Yeah, 10 is the right number. That's the only issue here. Yeah. Yeah, that's cool.